want to give you an analogy for what it's like to take measurements in quantum mechanics. When we take measurements on anything, we mean that we're going to use some equipment, perhaps in a laboratory, in order to measure what's actually happening in the real world. And then those measurements give us back numbers with units, things like energy, like maybe it's 1 electron volt, or position, maybe it's 5 angstroms away from the edge. These are the kinds of things we'll get back from measurements. Now, a particle, a quantum mechanical particle, can be doing a lot of different things. We've talked before about how the state of the particle is just whatever it's doing, and whatever it's doing is encoded in the shape of its wave. Now, interesting things come up because waves can do just about anything, and so waves can have interesting shapes that may or may not correspond to the measurement you're about to take on that particle. When we make a measurement, it's a little bit like asking the particle questions. And here's the crux for quantum mechanical measurements. It turns out that when you make a measurement, only certain answers are allowed, and that set of answers has to correspond to the question you asked. That kind of makes sense, right? If you ask about where a particle is, you expect to get back position information. If you ask what energy does the particle have, you expect to get back an answer that says the amount of energy. When we take a measurement, we get back only certain answers. The answers have to correspond to the measurement that we asked. However, the wave can go into any particular shape it likes before you ask the question, before you take a measurement. A good analogy is actually that of a coin. So let's take a look at that. All right, so here I have a coin, and I could flip the coin, and it could come up heads or tails. Okay, so let's say we flip it. That time it came up, well, that's tails. Okay, for this coin, I could flip it again. It came up tails again. There really are heads here, so let's see if I can get heads. There, that came up heads. Okay, these are examples of measurements, like they might happen in quantum mechanics. I would find out what state the coin is in by observing it. In order to find out whether it was heads or tails, I observe it. I make an observation with my eyes. Photons bounce off of the object and enter my eyes, and that's how I make the measurement. Now, quantum mechanical particles are allowed to do a lot of different things. All right, so let me give you an analogy for some crazy things that can happen when you go to take quantum measurements. Let's say that this coin wasn't flat when I measured whether it was heads or tails. Let's say it was spinning. Okay, so let's say it's spinning. Oops. No, really, let's say it's spinning. And is it heads or tails right now? It's actually neither. I have to force a big change in the system in order to find out whether it's heads or tails. Let's find out. It's heads. Okay, so this is a good analogy for a lot of times when we take measurements in quantum mechanics. The particle could be doing something that does not correspond to the question I'm about to ask it. The very act of asking the question can cause huge disturbances in what the particle was doing. So we actually lose a lot of information about what it was doing. Now the particle is forced in a way that is not controllable by us. It's forced into a new state that corresponds to the question we asked. For example, the spinning coin is neither heads nor tails. But when we ask the question, bam, smash the coin, it's forced to become either heads or tails. Now it is that state, although I've lost the information about what it was doing before. This is a great analogy for what happens in a lot of measurements in quantum mechanics. We might have a particle in a pre-existing state, for example, that's in two places at once, but then when I go to look for the particle, the wave function will collapse into just the one spot. We'll talk more about that next time.